So let us talk about this problem. Consider a homogeneous gallium arsenide semiconductor. The temperature is T equal to T100 with donor impurity concentration is 10 to 16 per centimeter cube. Acceptor is 0. We have to calculate thermal equilibrium values of electron and hole concentrations. Okay, and for applied electric field of 10 volt per centimeter cube, we have to calculate drift current density. Now we have to repeat the part A D if ND is equal to 0 and Na is equal to 10 is to 16. So let us begin with this problem. First of all, we will write the thermal equilibrium majority carrier concentration of N type semiconductor. Thermal equilibrium majority carrier concentration of N type semiconductor is what? Nn is equal to Nd minus Na by 2 plus root Nd minus Na by 2 whole square plus Ni square. Okay, this is our equation number 1, right? We know that Nd is donor concentration, Ni is intrinsic concentration, and now the expression of thermal equilibrium whole concentration can be given as this is thermal equilibrium majority carrier concentration. Now we will calculate thermal equilibrium whole concentration. Pn is equal to Ni square upon Nn. Okay, this is our equation number 2, right? These are our two equations. Okay, so now we will calculate Nn. This is equal to, for first case, Nd is 10 is to 16 minus 0 by 2 plus root 10 is to 16 minus 0 by 2 whole square plus Ni is what? 1.8 into 10 raised to 1.8 into 10 raised to 6. Square. Okay, because at 300 Kelvin the intrinsic carrier concentration is 1.8 into 10 raised to 6 for gallium arsenide. Okay, so this comes to be equal to 5 into 10 raised to 15 plus 5 into 10 raised to 15. Okay, 5 into 10 raised to 15 plus 5 into 10 raised to 15. Okay, so this becomes 10 raised to 16 per centimeter cube. Okay, this is our Nn. Now we will calculate Pn. Pn is equal to Ni square upon Nn, so which is equal to 1.8 into 10 raised to 6 square upon 10 raised to 16. So this is equal to 3.24 into 10 raised to minus 4 per centimeter cube. Again move down. Now the drift current density J is equal to E mu n d into E, which is also equal to sometimes sigma E. Okay, so we have everything E mu n d E. Okay, So this is equal to 1.6 into 10 raised to minus 19 into mu n, 8500 centimeter square per volt per second into 10 raised to 16 is nd into 10 volt per centimeter. So this comes out to be 136 ampere per centimeter square Okay. Now for p type, there is part C. Repeat part A and B if nd equal to 0, n equal to 10 raised to 16. Okay. So here Na is greater than nd. Okay. So Pp is Na minus nd by 2 plus Na minus nd by 2 plus root Na minus nd by 2 whole square plus ni square. This is equal to 10 raised to 16 minus 0 by 2 plus root 10 raised to 16 by 2 whole square plus 1.8 into 10 raised to 6 whole square. So this again comes 10 raised to 16 per centimeter cube is pp. Okay, we got pp. Now np is equal to ni square by pp, which is equal to 1.8 into 10 raised to 6 square by 10 raised to 16, which is equal to 3.24 into 10 raised to minus 4 per centimeter cube np. Okay. Now again drift current density j equal to sigma e. For p type it will be E mu p Na E, which is equal to 1.6 into 10 raised to minus 19 into mu p is 400 into Na is what, 10 raised to 16 into E is again 10. So this is equal to 6.4 ampere per centimeter square is J. This is the C part. So that's it for this video. Okay, see you in the next video.